We understand the critical role of responsible water management in shaping the future. We are committed to delivering sustainable, reliable, and high-quality water solutions that meet the evolving needs of our clients, ensuring their continued growth and success. From steel production to the industrial processing, every project we undertake is focused on efficiency, sustainability, and long-term impact. We recognize that the industrial water security is vital for our economic resilience. This is why we continue to innovate, ensuring uninterrupted, high-quality water supplies for the industries in Duqm and beyond. Esteemed colleagues, water presents its own set of challenges: rising demand, conservation concerns, and the need for efficiency. But within these challenges lie opportunities. Opportunities to rethink industrial water management, to leverage new technologies, and to create a more self-sustaining industrial ecosystem. At Marafiq, we see these opportunities as a stepping stones toward a smarter future. Our partnerships with Duqm refineries and others are proof of our commitment to smart water use. Together, we are pioneering a future where water is managed wisely, recycled effectively, and used responsibly. Challenges like water shortage and the need for effective water recycling remain significant. But we are confident that with the best practices in the industrial water conservation and efficiency, we can minimize the environmental impact while optimizing resources. Investing in the right infrastructure is crucial to ensuring that the water remains a sustainable resource for the industrial growth. As I stand before you today, I call all the stakeholders in this room, from investors and authorities to businesses and innovators, to join hands in making Duqm a model of industrial water resilience and sustainability. Together, we can ensure that Oman's future is built on the foundation of not just a strong industrial base, but a strong and sustainable water future. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Abdurrahman. This concludes this keynote speeches for the morning. We now have 3 technical talks, beginning with Saud Shwidani from ABSAR. So Saud is the Director General of Water and Wastewater Regulation from the Authority for Public Service Regulation. Saud.
السلام عليكم ورحمة الله وبركاته. في البداية أحب أن أقدم الشكر لكم ولي الشرف أني أوقف أمامكم. هذا العرض بيتكلم عن الريجوليشن بشكل عام في السلطنة. معظم الأودينس عرب وإنجليز فبنتكلم باللغة الإنجليزية. Regulation of Industrial Waste in Oman. Now, ABSR. I will start with this screen. I think this will give us very clear where our positions. In 2023, Royal Decree number 40 set whose will be policy makers on this sector, whose will be regulator, whose will be service providers. So we'll start from here. There is Ministry of Agriculture and Fisheries. This is as a policy. So the government represented by Ministry of Agriculture. We are, as a regulator, ABSR. We have also Ministry of Finance, because most of service providers at the current stage, they get still subsidy. We have also Environment Authority, part of the policy. We have two main operators signed as operating company, and we have another service providers on the next screen. At this presentation, talk about the industrial. So we have main key players. We have Oman Water, and we have Dhofar, those two main operators. We have also another classifications, Majis in Sohar Port, and we have Marafaq currently in Ad-Duqam. We have also Madain and Khazain, those current operators. Some of them already licensed, some of them on the way to be licensed. Still, there is a part of like oil and gas, still we didn't touch it at this stage. That will be in future. And also there is another industrial like self-supply, still we are not interrupted. And there is also some exempted like another fields. I think this definition, general definition, all the waste or the water will be produced with contaminations, any kind of hazards is not allowed to be discharged to the environment, whether it will be sea environment or air. We are, as authority, give the license to the service provider to make sure we are tackle and manage how to manage the industrial waste before discharging to the environment, to protect the human being first and the other agriculture from any contaminations and hazards. As I said from the first, we are now in the Royal Degree number 4023. There is a lot of articles, but I just highlight number of articles is talking about the industrial waste. So we have article number 10. No person allowed to discharge waste resulting from any commercial, industrial, agriculture, or medical activity that contaminate hazards, elements, or required any special treatment into the water wastewater network of the licensee, except after obtaining the licensee approval will fit all the conditions. So definitely there is a lot of industrial on these markets who discharging the waste, but there is certain condition to be considered. Article number 3, the authority shall issue the regulation, decision, directive necessary to implement all kind of regulation need to be implemented to protect the environment. And article number 3, the authority shall issue the regulation, decision, or directive necessary to implement provision of this law. So we are dependent to the regulators, we are dependent to the operators who will be licensed, and we are trust to the licensed operators. That's still allowed to some industrial to make their own treatment. The law is accepted, but subjected to make sure all the discharge from their industrial to be within the specification allowed to be discharged. And also we are dependent to the operators. Operators, they are responsible to make sure and cover all the demand in futures. So we have some kind of future planning for all the requirement within to build this industrial in future. Also there is two regulations, one on regulation 114/2001, this is by the ministries, and we have another regulation 55/2002. More details on there, but just refer it here. Establish a regulation framework in Oman starting since long time, but as a regulator in 2023, we start to look after to all the industrial, I'm talking about the water and wastewater industrial, include industrial waste. So there is a lot of requirement, but as today we are in 2025, still there's 2 years. There is a lot of effort in this country to be built to make sure we are looking for the future with a safe environment. And the government's design, and there is a lot of effort to build the economy. But we have to make sure we are not polluting the environment, because this is our land in the forest and we are living here. And this is my presentation, and if there's any questions later, we can answer. Thank you.
Thank you, Saud, for the brief and very informative talk. The second talk is by Fahd Al-Abri. Fahd is an energy and water policy advisor in Petroleum Development Oman.
Assalamu alaikum. Today, actually, I'm going to talk about video water management strategy. Linking with Hani talk about seeing the produced water as a source. That's this presentation, it will be on that subject, actually. As a simple definition of a strategy, it is a method, actually, to overcome the challenges, or it is to meet certain goals, agreed goals. Today, I'm going to talk about water management in video as overall view. And then we're going to talk about video water. Partially generating a value, but not fully. We'll describe that later on the coming slides. We set goals for our strategy. We have 3 goals which set as part of our strategy is to maximize monetization of the surplus water, which we have actually, we keep it now on the surface handling, which is on the evaporation. And also to have zero disposal or deep water disposal by 2030, which we are actually having a clear roadmap to reach our aspiration by 2030 to have deep water disposal by 2030. And the third goals, which we have to reduce the exploitable aquifer to LR as low as reasonably possible. That's for the use of the aquifer for the oil and gas utilization. For example, for water injection and for crude washing. This is listing you also as the challenges which we are facing currently on the produced water, which is actually keeping or moving the project. Some of the project now is kept in the visibility. This is the major challenges which we have within the Block 6 that within the managing the produced water. First one is the high project cost and commerciality. This is one of the challenges which we are facing currently. Lack of regulation for the produced water reuse options. We don't have a clear regulations for reusing the produced water. And the geographical spread to centralize the solution. As you can see from the map, we have the opportunities across Block 6, which making difficult to centralize our solution. Lack of incentives also for low CO2, because now we don't have a or incentive for the CO2 to consider it in our economics, which making the project viable. And water contaminants in BDO across Block 6, we have different water quality, which make the solution different across the Block 6. That's also one of the challenges. We cannot replicate all the solution within Block 6 for all the opportunities. And lack or limited investors. We are looking for investors to invest actually and to provide their solution or to invest, and also the technologies to resolve some of the challenges and the opportunities to utilize the produced water. Going for the BDO water utilization, as you can see, we have the forecast for the produced water. The bars is representing actually the utilization percentage or utilization of our produced water. As you can see, the brown bar is represent the water injection. As we can see, on 2024, we are actually utilizing 70% of that produced water, which we are saying that we meet the value creation by this stream. The other utilization, which we are using currently of 17%, that is going for the surface water handling. And mainly this we are talking about reed beds and REMA water treatment plants. Partially, actually, we phased out the DWD. We partially solve part of the solution, but still that water is kept on the surface handling, which actually we want furtherly based on the strategy to utilize and to create a value from that produced water, which is kept for evaporation. And the 13%, that is represent the DWD, which is actually, we are not generating any value from that stream, which is actually energy incentive stream, which we want to monetize and create a value from that stream. As you can see, actually, we set our strategy to have a 2030 frame to actually, for example, I present the goals of having zero disposal. Currently, actually, as per the forecast which we have, we are going to have deep water disposal around 5%, and the surface handling is going to be around 16%. And also, if you can see, there is also a white bar or gray bar that represent actually the coming project for salt and mineral extraction. Moving forward, where is the opportunities across 6? This is represent a map, a high-level map representing the size of the opportunities and the location of the opportunities within Block 6, which is represent the 30%, the surface handling, which is mainly, as I say, it is reed beds, which is in the light blue, and REMA wetlands. And what is the options which it is considered as a potential to actually monetize and create a value from the produced water? This is like a map showing you the opportunities which we maybe consider as part of our strategy. I will not go on the details, but the most important stream which we are considering is the water injection. Which to increase it actually, because that's the most value generation for BDO. The other things, for example, the hydrogen, tomorrow actually there will be a session for hydrogen. There is an assessment also in going with the hydrom to assess the reusing of the produced water. And the other also, for example, plantation, use it for CO2 sequestration, mineral extraction and salt making. That's we are working in some of the projects currently. This is a funnel, high-level funnel, showing you our projects from different stages, which we have, for example, in the visibility. Still, some of the projects staying on the visibility because of the challenges. And we have a mitigation we are putting in place, actually, to overcome the current challenges. As you can see, maybe we'll highlight only on the major project, actually, which is achieved by our strategy. It is the Namur reed beds, which is a famous project, and Rima biological treatment plant, which is on Rima, which is in operation since 2022. And we have also, as a relocate of our produced water, because we said in our strategy is relocation, and the definition of relocation actually to relocate our produced water from the access fields to the shortage fields to utilize it for water injection to generate value. And this is an example which we have from Yibal to Al Khwair, relocation of the produced water. And this is the last slide, which we have. If you can see, we cannot meet our strategy and implement it without collaboration and also collaborate with other entities and third parties. Thank you very much.
Thank you, Fahad. Our last talk is by Ahmed Al-Muqbali, who is a process engineer from Majis Industrial Services. Of course, after the talk, I will ask the three technical presenters to come forward so that we have a brief Q&A session at the end. So, Ahmed, the floor is yours.
Good morning. It is actually my pleasure to be here today and to present Majis' strategic approach for NRW reduction. So actually NRW is the key challenges for most of the utilities and water distribution company, since it is not affecting the operational efficiency only, but it is affecting the financial performance and customer trust as well. So we are at Majis, we are addressing the NRW reduction as the key challenges, and we implement our strategic approach to reduce the NRW. So today, through my presentation, I'm going to explain, and I'll go through Majis' strategic approach for NRW reduction. So the agenda of my presentation, I'll start first with the introduction, which will include a brief introduction or definition for NRW, refer to the international standard. Then we will talk about NRW calculation and the classification of water losses. After that, we will see the importance of reducing the NRW. Then we will see Majis' strategic approach in NRW reduction. After that, we will see also the Majis' continuous plan for reducing the NRW. And finally, we'll present or show Majis' success story for NRW reduction. Coming to the definition of NRW, basically the NRW is the correspond of water losses due to physical and commercial losses. And as per the International Water Association, actually they are classifying or categorizing the type of the total volume which was entering to the system in two main categories. The first category, which is authorized consumption, and the second category, which is water losses. So once we come to the first category, authorized consumption, we have two different types, which is authorized bill consumption, and that one forming revenue water. And the second type, authorized unbilled consumption, which is forming non-revenue water. The second category, which is water losses, also having two different losses or two different types, commercial loss and physical loss, and both of them forming non-revenue water. How to calculate the NRW? So basically NRW is a combination of physical loss and commercial loss. But how we can classify these two different losses? We'll start first with the physical loss. So physical loss, it is loss due to deteriorating infrastructure, insufficient maintenance practice, and poor pressure control. The commercial losses actually, it is the loss which was caused by inaccurate metering system, unauthorized water usage, and incorrect billing data. The importance of reducing the NRW. Why we need to reduce the percentage of NRW? In fact, there is many advantages of reducing NRW percentage. For example, by reducing the NRW, it will reduce the revenue losses and optimize financial sustainability. Second, by reducing the NRW also, we can ensure that ensure efficient water distribution system and enhance sustainability by minimizing the waste. Najee's strategic approach in NRW reduction. Actually, Najee's strategic approach is a combination of technical, managerial, and policy measures aiming to identify the reason of the losses and implement the effective solution to reduce that losses. So Najee's strategic approach, we can summarize it as following. Starting first with assessment and data collection. Next, physical loss reduction. Third one, commercial loss reduction. The fourth one, implementation of technology integrated and innovation. Fifth one is performance monitoring and continuous improvement. Let us now take it one by one and explain it. Started first with the assessment and data collection. First of all, for monthly review and update. We are conducting a monthly review and for the data of water produced, pumped, and distribution. Second, mass balance calculation. Actually, we are conducting also the mass balance calculation for our water to determine any losses by collecting the data of production, the data of pumping, and the data of consumption as well. The last things, benchmarking, set up the benchmark to check the performance of our system. And we are setting the benchmark compared to other. Here we have one case study for assessment and data collection. So from this graph, you can see that we are collecting the data on a monthly basis for the total volume of water, which is produced, pumped, and consumption. So this figure gives a good indication if we have any losses in our system. Let us now shift to the second type of or second approaches, which is physical loss reduction. So for physical loss reduction, started first with leak detection and repairs. So we installed more than 58 noise logger in various locations at our network and our system to determine if there is any leakage. Second, creating regular schedule maintenance for our assets. And also we are conducting manual leak detection to detect any leak at any suspected leak area. Second, pipeline rehabilitation. Actually, we are conducting also asset condition assessment, and we are inspecting our pipeline to evaluate and assess the condition of our pipes and plan for the replacement. For pressure management, actually we are installed at different locations. We installed pressure transmitter starting from a pumping station up to the customer end. And also we are improving our pressure pressure management by installing VFDs and flow control valve at our pumping station. Here we have case study number 2 for physical loss reduction. As I explained, from first photo you can see we have leak detection, manual leak detection, which was conducted at any suspected leak area to identify if there is any leakage in our system. Then we have also noise slugger photos. So this photo shows the noise slugger which was installed in various locations at our network. And finally, the VFDs, which was installed in our pumping station to control the pressure and manage it. Moving to the commercial loss reduction, and starting first with metering and billing enhancement. So we already replaced our mechanical flow meter with electromagnetic flow meter, which give high accuracy. And also we are doing the meter calibration regularly to ensure that meter showing the correct value. For unauthorized connection, actually we are doing also or conducting regular network inspection to identify or to detect any illegal connection. In addition to that, also we are conducting a zero test flow to ensure there is no hidden consumption to our system. Finally, for the bill data verification, all the data for the data of billing, it was verified by and signed off by all concerned parties, include asset team, operation team, finance, and client management. Here we have study case number 2 for commercial loss reduction. And we have the first photo. It was showing the flow meter calibration. So as we said, this practice, we are doing it regularly to ensure that flow meter is giving the correct value. And we have also another photo for zero flow test. Actually, this photo showing the distribution of our network through Sahar port. And we are conducting this zero flow test after coordinating and communicate with our customer to ensure there is no impact on our customer end as well. Innovation of technology, integration and innovation. Actually, we implement some technology like CMMS, computerized maintenance management system, which give a proactive schedule maintenance for our assets. And also it is good and give good indication for our asset performance. Advanced flow meter measure, actually we are change the selection of our flow meter with high accuracy flow meter, and we minimize the accuracy error from 5% to 2%. Categorization of network, actually we categorized our network into zones, DMA and DMZ. GIS and remote monitoring, actually we are mapping our pipeline and our network on GIS for easy tracking of maintenance. LoRaWAN implementation to give a connection or real-time connection of the pressure transmitter and flow meters to SCADA. These things will ensure that we have a continuous monitoring of our operational performance. Performance monitoring and continuous improvement. First of all, when we talk about the performance monitoring, KPIs for reducing the NRW, we are establishing the benchmark and setting the KPI to check the performance of our system. System upgrade and innovation. Actually, we are in collaborate with the technology provider to check the update of the system with them. Emergency response. So we have a maintenance team who is available 24 hours by 7, and they are ready to attend any leak immediately. NOC management also, NOC team, we establish NOC team for clear communication with our customer during any emergency leak. This plot diagram actually it is showing Majid's journey plan for NRW reduction. So as we previously explained that we already implement most of these actions and we have some or few action which is in progress, and we are planning to continue also this one during this year, 2025. So Majid's success story for NRW, from these figures, you can see that on 2023, the NRW percentage, it was 5.5. Then after implementing our approaches, we reduced the NRW percentage to 2.5 during 2024, which means we are achieving a reduction of NRW by 3.3%. At the end, I'd like to see that NRW is it causing a challenge for operational and financial, and also it's leading to lose revenue and increase maintenance cost. And we are implementing our strategic approach, as we explained, by reducing the physical loss, commercial loss, and also adapting a new technology and tracking the performance of our system. We are, as Majid, we achieved a good reduction of NRW percentage. Thank you.
Thank you, Ahmed. This was our last talk. I would like to call Saoud, Fahad, and Ahmed to join me the front seats here for a very, very quick, it will be short and sweet. I prepared a few questions, but probably because you take priority, if there are any questions, please raise your hand. Mike's on.
I would like to thank all panelists for, I'm here, okay, for presenting their success story in all fields. Actually, my Abdel Nasser Mabrouk, Gulf Core Company, Qatar. My expertise very in salt making. So my question to Fahd, it's okay. Would you please highlight the outcome of visibility study for salt making in terms of what is the best technology, revenue, energy consumption? I would like to hear about this.
Currently, actually, we have, as a visibility, we found it is a viable project, actually. We have two projects currently is going on, one in Fahoud, salt making, and the technology is to harvest actually the salt making by evaporation bonds as a simple one. And the idea actually and the concept is to utilize this the salt making for our industrial use, like in the drilling. And the other project which we have currently also, actually it is also collaboration with MDO, is to generate bromine from the produced water. And this is also a viable product, which is actually, this is maybe it will be the first kind of a project actually executed in the produced water. Because currently the bromine is extracted from the seawater, and there is also countries which they are really focusing on producing the bromine. Yeah, that's an overview.
Assalamu alaikum. My question again is to Mr. Fahad. My name is Gibran. I work with George Fisher. I want to know the developments or advancements which you are working on for the produced water treatment. Like there are a lot of technologies out in the market right now. Like, is it only that you are waiting for an investment on this? Is this, I mean, it is a subsidiary for you. I mean, it's a second thing for you, but as 70% of your water is going into injection. So are you working on any new technologies? What kind of enhancements we can expect in the future? Or what kind of associations you are looking for? That's my question.
Thank you for your question. That's very important, actually, question, which is a really good question. In terms of the 70%, as you say, which we are generating value, but the 30%, we actually kept our strategy to focus on that, to untap the potential of the produced water. There is a different technology which we are looking for. And also, actually, if you can see that we raised one RFI in October last year, actually looking for investors or technology providers to invest on the produced water. Because the pathways which we are defining as part of our strategy is because we have a high cost and we have a commerciality challenges. We want investors actually to come forward and provide their solution to invest on untap the potential by whatever defined revenue streams which they are defining as part of their technologies. And the RFI which we have actually for number reed beds to monetize that surface water which is kept in evaporation. And there is actually different technologies. Maybe I will highlight some of the benefits of that. Actually, we got proposal actually to produce a biofuel, SAF. We have also some of the project to also do a plantation to get carbon credit and for CO2 sequestration. This is kind of the technologies and the value streams from these technologies. And there is also one part which we are considering as part of our technology is like to look end-to-end solutions. It's not to look only on to solving the solution, the problem of the water only. We look at widely and end-to-end solution to actually make this project viable.
Good morning. I'm Pawan from representing Nafal Circle H2O team. So first of all, thank you to all the panelists. It was a very, very good session. And a special appreciation to the Majis team achieving 60% NRW reduction it looks to be easy on the slide, but too difficult to achieve on the field actually. So thanks to Majis team. And my question to Majis and PDO is that the Majis has successfully implemented a very good plant and water management system, recycle plant in Sohar Port. So is there any plan for, PDO has also expressed the challenges in the partnership, investments, and technology, area where the produced water to be handled. So is there any plan where Majis and PDO is getting collaborated with expertise of the Majis with so many successful stories in the seawater as well as in the recycle plant, produced waters? So is there any plan of such where Majis and PDO is also getting collaborated in future?
So that we utilize the expertise of Majis and as well we carry benchmarking exercises.
Thank you. I would like to thank Fahad, Saoud, and Ahmed for their great presentations. My question is to Absar, to Engineer Saoud. So how can Absar support in linking industries like BDO, Oxy, the oil field industries, with the water industries companies like Marafiq and Magis, to have the best utilization of the water produced from the oil fields? So that can be utilized, let's say, to have it a better resources, and we can utilize it in the industrial operations in Oman.
Thank you, Ayub. I think the ABSR is looking from the regulation perspective. Yes, we encourage the champions of what we have. We have Majis, we have Marafiq, which they have very good track record in terms of the country. And those experience, we encourage them to enter another areas with cooperation with another whether it will be oil and gas or another industrial area. And we are, as authority, we are willing to discuss any kind of license and obligation that would be suited for all partners, whether it will be BDO or Occidental or another oil and gas sectors. Oman is distributed as a clusters. So we have seen there's a lot of players now. From economic of scale, it's very challenging for them to locate in only in very small area. Opportunity, we need to look at from the opportunity perspective. Yes, the answer is yes, and we are fully supported. We are looking for the industrial regulation. It's only technical regulations, not technical economy. If there is both parties, they are agree with the way of how they are tackle the commercial part, we are only interfere and give license to the technical part, because Ministry of Finance, they are tackling the subsidy only for very specific industrial at this stage. Thank you.
My name is Mushtaq Ahmed. I'm from Sultan Qaboos University. As to Ahmed, about non-revenue water, the number we are familiar with Omani network water is this system loss is around 40%. 22, 23 data, but you showed that it is 2.5%. I'm sure you're talking a different thing. And what you have done, reducing 3% in 1 year, whatever area you're talking, is really good, because it's not that simple to reduce that much in a broader scale. And also to Fahad, that this 70% of flooding, is that really needed, or you have no better choice? If you had choice, you would use this water for something else, because flooding creates also other issues like that ratio goes up and up and up. So is that 70% really needed, or it's that you have no better choice? So to Majid, that what area, what amount you talking about, and the other one is for PDO. Thank you.
Thank you, Dr. Mushtaq. Yes, actually, that the number which you saw, 3.3% reduction in 1 year. Just I need to clarify that we are, as Majis, we are dealing with the industrial customer, and we are supplying the water to Sahar Port and Sahar Free Zone. So we have a limited network, which make it easy for us to detect and to monitor. And the availability of the team, maintenance team, to attend any leak immediately. This is one reason also for achieving that number. Additional to that, also we have a single source for production, maintenance, distribution, and collecting the data. Thank you. I hope answer your question.
Doctor, thank you for your question. Regarding the 70% for the water injection, as a simple answer, it is needed because also we have WRFM teams which are actually working to optimize and increase the efficiency of the recovery. That's now currently it is needed. And actually on the future forecast, if you can see, there is increase because that's a need of the new fields because it's getting older to maintain the pressure on the reservoir. Yeah.
Thank you.
Assalamu alaikum. My name is Raju Sekharan from Nepal. My question is to Farab sir. This wastewater reuse standard, it's a norms and the regulation is going to be upgraded. Or I think we have 20-25 years back the regulation royal degrees established. Good to know a lot of other royal degrees is upgrading, but wastewater reuse royal degree, are we going to have any upgradation? Thank you.
Thank you for your answer, for your questions. Yes, I think the ABSR started first. It's our obligation now to update drinking water standard and bottles, and also the wastewater. Regarding the reuse, we are cooperate with another ministries, and now the team already formed. Now we are in the progress. We expected before the end of this year, we'll have new published reused wastewater with there is a lot of update on even the parameters to cooperate, and also we are discussing now different approach to classify what kind of reuse. Then we'll have certain classification, and I think by the end of this year we are going to have updated also for the drinking water.
Assalamu alaikum. Thank you very much for all presenters. My name is Abdul Salam. I'm concept engineer in PDO. Several things I want to talk about. First, about lithium extraction. We know that we have salt making projects now already FID'd. Have you explored lithium extractions? We know there is a big market for electric cars, so we can make lithium from that. Second thing about the hydrogen. In one of the presentations, it's already past the feasibility and it's now under FEED activities. We have heard a lot of rumors about the commerciality of hydrogen production, and can you elaborate more on that? Thank you.
Thank you, Absalam, for your questions. Answering the first question about the lithium, yes, we do investigate and assess the lithium extraction because within BDO, actually, we have low concentration, actually, of lithium, but there is some of vendors or some of the technology providers, they offer, actually, that they are claiming that they can extract lithium from our produced water. And we do that, and we actually investigate as part of the project, for example, the Hyper Saline project in Qarna Alam, we are looking for that opportunities. As the concentration of the lithium, seems it is good to be extracted, and maybe it will be economically viable on that. Regarding the second question about hydrogen, actually, a part of the assessment and first visibility of based on the hydron, they want to assess two options because their concession area of producing the hydrogen is near our concession areas of the produced water. They did actually with the consultant high-level assessments, and to investigate the option of using the produced water to produce the hydrogen. Still, actually, the first assessment is showing it is not economically viable, and actually there are another assessment or detailed assessment to be done from their side. Did I address your questions? Okay, thank you.
Good morning, everyone. Hawra Jali, project engineer from Marafiq. Congratulations to Majid's team for this great achievement. Actually, I have two questions to Engineer Ahmed. First one, what are the lessons learned that you have captured during your journey in RW reduction? The other questions, does Majid have a target or vision to further reduce NRW percentage below 2.5?
Thank you, Hawra. To answer your question, actually, yes, Majid, as we said that improving NRW reduction is our journey, and we are in continuous to reduce that number below than 2.5. And hopefully, inshallah, by 25th, we can reduce the percentage less than 2.5. Regarding the lesson learned from whatever we implement, actually, there are many lessons learned. For example, accuracy of the flow meter. So while you are selecting the flow meter, you should select the flow meter with high accuracy. And also another important thing is that the sizing of the flow meter having a role also in the accuracy of the readings. So what we found in our cases for the commercial losses part, we found some flow meter which was not installed as per the manufacturer recommendation. So as per the manufacturer recommendation, actually, the distance at the inlet and the outlet of the flow meter, it should be matching whatever specification for that flow meter. But in some of our cases, we found some difference. So we already reinstalled that flow meters. This is the main lesson learned from our journey.
Okay, thank you, Ahmed.
Welcome.
This will be the last question.
Assalamu alaikum. My name is Rahiq. I am Dr. Mushtaq student. So my question is to Mr. Fahad. I would like to know the intended use of the treated water from the three projects, and what is the water quality standard you want to meet or want to reach after the treatment?
I didn't hear well the first part.
Yeah, what is the intended use of the treated water from the three projects in the BDO? And what is the water quality standards you aim to meet after the treatment?
Okay. Regarding actually the three projects, I think you are talking about reed pits, which is showing the photos of it. Okay. Actually, the three projects which we are currently, the intention it was actually to phase out the DWD to a surface handling, low energy surface handling technology. And that's why actually we introduced and we executed this project actually mainly to save energy and reduce the GHG, because on the DWD we use intensive power, and that's one advantage we got, and this is again for us. Additionally, actually we see this as a resource, and we want to treat further this produced water to be used, for example, for irrigation, to do a plantation. And from that part, as based on the proposal which we received, there is a potential option to be used, for example, biofuel, production, biodiesel, SAF production, which is actually, this is generating value streams. This is to be considered for all our opportunities. Noting that actually we have different water qualities within the block 6 varies from the brackish to the hypersaline, which is making each area to have different solutions. As we mentioned also, we have projects on the stream to produce the salt that is considered for the hypersaline and the saline water quality.
Thank you.
You're welcome.
Okay. Thank you very much. Sorry, we ran out of time, but I was really very lucky because I worked with all presenters here and with their entities. I know that there is a national committee with Oman Vision 2040 for the standards and produced water. I worked with Majis a lot, and I know how extensive and how complicated their process is because they take the water, they provide the water, the cooling water, fresh water, and of course they take all kind of wastewater as well, whether refinery water and others. They do a lot of neutralization probably and standards. So it's really complicated. The whole process is complicated, and what the work that they do is really outstanding. The same challenge is also for APSR because it's not only dealing with what we know. A lot of companies now and others are using new chemicals, and these chemicals, they always return back to the water. And so regulations, standards, they are need updating every now and then. So big challenges, but everybody is working extremely hard. I know how hard working PDO is in all of this with the wetlands, deep water injection, all kind of work that is happening in there. I would like to thank all of the presenters, the keynotes, and the technical talks. So beginning with Hani, thank you very much for taking some of your time to visit us here in Oman. It's always a pleasure to see you. With Engineer Ayub, Engineer Abdul Rahman, of course, Saud, Engineer Fahad, and Engineer Ahmed. It's a real pleasure and honor to stand in front of all of you here, and we have this. I think it's time that we really highlight and shed a light on the industrial wastewater, and I am glad that we have this year in Oman Water Week, and I look for more productive sessions coming today and tomorrow as well. Thank you very much. I think we have
Please remain on the stage. As a thank you, we will be delivering certificates of appreciations for the presenters. So, thank you. First, with the presenter, Engineer Saud Al-Shaidani. Engineer Fahd Al-Abri. And Engineer Ahmed Al-Maqbali. Speakers, please get back to the stage for a group photo. So as the keynote speakers as well, Engineer Hani, please, Engineer Ayub, and Abdurrahman Al-Kharousi. Thank you all. Now, please, you can have the coffee break and be back to the hall at 11:10. نعم. دقيقة أوكي ماشي. لا مش دقيقة. طيب عشان I will introduce. طيب ماشي. Everyone, please be seated because we're about to start. everyone. Now we're starting session 2, Innovative and Sustainable Solutions for Industrial and Produced Water Management. The session will be chaired by Engineer Saada Al-Shukaili, Head of Water Procurement from PDO. Please come to the stage. Please welcome Engineer Saada.
Assalamu alaikum. I'm Saada Shikeli, Head of Water Management and Subject Matter Expert for Water Processing and Petroleum Development Oman. I'm glad to be here to chair this session. It's about advancing water production by innovation and applying best practices for sustainable solutions. We have the first speaker, so there is a change a bit in the order of presentation to some presenters, changing flight. So we welcome Mr. Saeed Haider from Nasser. He's the technical sales manager in Nasser. Please. He will be speaking about produced water desalination for zero mineral and liquid discharge.
Assalamu alaikum everyone, good morning. I am Syed Haider, Technical Sales Manager for Nasser Gulf Energy Decarbonization Portfolio Segment. And what we are focusing on right now, today, most important two critical aspects of our industry, water and the value it holds. And that's what we are going to address in this presentation. I'll start with the ratio, 7:1. So this shows that for every barrel of oil produced, on average, combined GCC countries, we are producing 7 barrels of water. And we consider this as a byproduct for now. So the real question is, what value does it hold, this byproduct, which is just being disposed of right now? Interestingly, we had this same situation exactly approximately 150 years back, when fractional distillation was not so common and we were extracting less products from the crude oil that was being produced, and a significant volume of it was being disposed of as a byproduct. So we are in the same situation again, and now it depends on us, how do we address this issue? So in the upcoming slides, I'll be share how Nasser and Gulf Energy is actively engaged in this sector and trying to make a meaningful contribution. I'll be going through opportunities that lies with us, but what are the problems that must be addressed to make it meaningful? Some case studies we have successfully rolled out in GCC and the results. So for now, I mean, globally around the world, out of whatever is being produced in terms of the produced water volume, we have 3 main ways of getting rid of it. Either we are dumping this, re-injecting this back into the reservoir for maintaining the pressure, and for the EOR. But there is negligible to zero water treatment cases and reuse in the industry for the produced water. Just to put things into perspective, for example, for GCC, in every single day, we are producing approximately 112 million barrels of water. And if we treat just 10% of this water, it's going to supplement the annual freshwater household demand of almost all GCC countries every single year. So the opportunity is huge. But the problem is, produced water is dirty. It's really dirty. There's all kinds of contaminants we can imagine of, from H2S to heavy metals to other suspended solids and lots of other things. So we at Nasser are trying to make this whole project more technically feasible and economically reasonable. So our aim is to completely flip the project economics, because right now this is super expensive and does not add a lot of business value to the projects which are ongoing. And the main technology that we have been using to achieve this is DIVR, dynamic vapor recovery. So this is a thermal desalination technique, and the basic fundamental is to let the water boil at much lower temperature. And how do we do that? By creating negative pressure in the system. And the technology we have used has great benefits to offer. We are talking about treating hypersaline water with TDS values above 200,000 ppm. The recovery rate is much higher, and the energy consumption is much lower because the steam that is being generated in the system is being reused to heat the feed water and make the entire process as efficient as possible. And the most important and the critical aspect, getting the minerals out of the reject brine. That completely flips and changes the overall business value. So we had this great project in GCC. We were targeting produced water, and the salinity was as high as 270,000 ppm. And we had two main focus areas. Obviously, we had to pre-treat this and then pass it through the diver to get fresh water and minerals out of it. So it was treated for H2S, TSS. For H2S, we targeted less than 10 ppm. For suspended solids, less than 25 ppm. And per day, treatment capacity was 30 meter cube, or approximately 200 barrels of clean water production every single day. And with DIVR, the treatment was, the main objective was to treat water above 200,000 ppm, as I mentioned. And the target TDS values for the clean water that was being produced was less than 200 ppm. So that's close to the drinking water TDS values that we have in these water bottles in front of us. And finally, once we produce the clean water out of it, the most important aspect, the concentrated reject, that's where the real value lies, and we generate value. So a few important things to mention here. We have the technology, and the most important aspect or critical thing we were trying to achieve was to have continuous operation for 24 hours. It has to run continuously. That was one of the prime objective of this project. And we managed to do that. The second was, we varied the TDS values by diluting the feed water, and we played with a significant range, starting from 85,000 ppm up to 270,000 ppm. And during this entire range of TDS values, the operation was great, with average recovery efficiency of approximately 75%. And with TDS values of the reject brine, of the clean water that is being produced, less than 200 ppm. So the graph on the right-hand side, this shows the specific gravity of the distilled water which was produced. So that's close to 1 compared to the specific gravity of the feed brine. Now, fine, we use DIVR, we produce clean water, great value. Can be used for agriculture, for other industrial uses, or after other necessary pre-treatment for household uses. But that does not help in running the project, because you are not yet able to recover the money. And that's when we started targeting the minerals. Not just one, but a lot. So just to start with, first we produced sodium chloride, 99.6% purity. And we did not stop there because this water from GCC had other valuable minerals too. This had calcium, magnesium, strontium, and barium. So we precipitated calcium carbonate, magnesium carbonate, and strontium carbonate successfully from the reject brine that was being produced. So feed water goes in, produce the clean water, and this is the concentrated reject brine from the diver. And this is being used to produce these high-value minerals that is being produced here. So just to put things into perspective, so that we can have a better idea about the economics we are dealing with here. So this was a pilot project. Now let's suppose you take the example of $100,000, 100,000 barrels of produced water treatment. You have a plant, 100,000 barrels. How much money can you make out of it based on the results so far we have here? So based on our internal calculation, every day, the amount of the salt that was being produced, if you use the international market rate, it's easily going to generate approximately $150,000 of value just in terms of the minerals that is being produced. And that completely changes the overall economics of the project that we have been working on, and that completely changes the game. So in summary, we tried DIVAR, two main objectives, have the fresh water and the high value minerals to be produced. And the other additional benefits that include is obviously because now the VCM market, the voluntary carbon market, is catching up soon in the GCC in general. So the verified carbon credits can be easily sold in the voluntary carbon market. And you get rid of many other things because right now you're producing the water, you need to take care of the disposal cost, all of that is being taken care of. Fine, that's great. We have a project, we generated value out of it. But I personally see this more than just business we are trying to make here. And that's why I have this last slide, little bit different in front of us. So we have the water stress map on the left-hand side, projected for 2050. And the situation does not look good at all. And on the right, we have the ruins of the Indus Valley Civilization 3000 BC, and that was completely gone because of the lack of water. So we must act, and we must act responsibly, and at the same time generate enough value. Thank you so much. And just to finish off before, because I'm really sorry because I have my flight to catch, but I have my colleague here, Majid Al-Qassabi from Saco Energy. Please get in touch with Majid if you have questions. I would love to engage more on our pilot and the great results we have and discuss further. Thank you so much.
Thanks, Mr. Haider, Sayyid Haider. Will you be able to answer any questions?
Yeah, I would love to.
Okay. Anyone has a question? It's okay. Okay. We have three.
Yeah, I can hear you well.
Thank you very much for valuable presentation with this pilot. And I'm just not questions, and I would like to know just what's the difference between this DIVAR and the conventional mechanical vapor compression or mechanical vapor compression? Is there any difference in design?
Slight difference in the design.
Can you highlight it?
Slight difference in the design. First, obviously, the most important difference is the energy consumption.
How much? Yeah, this is the second question.
Energy consumption. This is a little bit on the lower side, DIVAR, approximately 10 to 15. So for the pilot, we had.
You cannot calculate it.
So that was not so efficient because that was pilot. We were trying to optimize lots of things.
True, yeah.
But the large scale we have been working on right now, that's approximately 10 kilowatts per barrel, 10 kilowatt hour per barrel.
10 kilowatt for how much energy recovery?
10 kilowatt hour per barrel of distillate.
I mean recovery, sorry, water recovery. No.
10 kilowatt hour per barrel of distillate. And you compare that with, sorry?
10 kilowatt compared to about 20, so too much
Yes.
reduction is good.
Yes, and but again, even 10 kilowatt is a big number. If you try to compare this to other conventional technologies, I mean, it's a lot cheaper, maybe by a factor of 10. But then the whole project economics gets flipped out because of the high-value minerals we are generating during the process. And that's where the whole process changes.
Okay, just this 10 kilowatt up to crystallization or just...
Okay, so we have the divar, we have the brine going in, and we have the clean water coming out. So this 10 kilowatt per hour, per barrel, is for the clean water that is being produced. For each barrel of clean distillate we produced, the energy consumption is approximately 10 kilowatt hour. And we are working on other design optimizations too for the heat exchanges and the type of the steam heat generation system we have for the initial heating of the brine. So all of that is being taken care of and takes care of the overall energy consumption.
Last one. For sequence of salt precipitation,
yes.
Calcium carbonate should be precipitated before NSL.
Yes, that was a mistake. Before you take the divalence, then you go for the monovalence. So that's a good point.
Thank you, Sayyid. This
yes.
is Hani Khalifa. I would like to request you a brief explanation of how did you segregate all these salts?
Okay.
What's the process that you used to
Okay, so this is mostly chemistry-driven process. We know by the ICP analysis what elements are there, what minerals are there. So obviously based on the stoichiometric relation and based on two things. Obviously the pH is the most important driving factor here. Based on the pH, which mineral is going to be precipitated first, and that's the order we follow by basic chemical precipitation. And we have this, so once all of this was done, we also worked on the mineral recovery pilot. So in-house, so we developed it right from the scratch, and that is soon going to be delivered to us. And it's a 40-feet container, and that's going to automate the overall process, right from generation to making it to powder to bagging and tagging, all of that. So all of that is going to be automated with our mineral recovery unit, which is supposed to be delivered to us soon, and everything is designed in-house. Yes, I can hear you.
Process, salt proc, to produce salt. First of all, what you have done is presented a very rosy picture. Reality is not like that.
Okay.
First of all, making money from salt is not easy. If we could do that, everybody would be a millionaire in Oman because we have a lot of salt in there. For example, sodium chloride per ton is sold for $20 to $30.
Yes.
It is not economic.
Okay.
And most of the brine that the desalination industry and other produces mostly sodium chloride. Unless you get some lucky magnesium hydroxide, those places maybe you will get some good value salt. And also there's water production. You said that 10 kilowatt hour per barrel, which amounts to probably 60, 70 kilowatt hours per cubic meter of water. And that is 30 times more than normal desalination. So it is highly uneconomic.
Okay.
But of course, there are some costs probably you are saving. You can put in this environmental cost, greenhouse, all those things. So selling getting the salt out in a clean state without requiring further processing is a challenge which is not easily. I hope you have done that, and it's only 30 cubic meters, but even in Oman now, every day we're producing 1 million cubic meter of desalinated water, which means that another 1 million cubic meter of brine. So it is a huge task. In a small scale lab, it will work, but I doubt you'll get the market, and you'll be producing so much salt, you'll also down the price. So good that you are doing that. In a small scale it will work, but on a larger scale it will not work. That's my.
I really appreciate your comment, Professor Mushtaq. And let me come back to the interesting points you mentioned. I'll take a few more minutes. Point number one, this was a small scale project, 30 meter cube, but we have gone much more ahead compared to where we started, 30 meter cube. We have already been working on, and it's in the commissioning phase, for the 10,000 barrel plant every single day, and with further scale up potential. That's point number one. So we are already past that scale, lab scale, XY. Coming to the mineral part, lab scale was done. So at our R&D facility in Saudi Arabia, we have been engaged on extensive R&D analysis since last 1.5 years. And the pilot mineral recovery unit, as I mentioned, is developed right from scratch and will be delivered to Saudi Arabia by the end of the April soon. So we are much further ahead compared to the lab scale where we started. Now, coming to the third and the very critical point you mentioned about the economics. Each water is different. The produced water in Oman is different from produced water in maybe Abu Dhabi, or produced water in the US, or produced water in Saudi Arabia. And extensive economic analysis must be done to understand where does the economic benefit lies. Maybe, as you mentioned, for example, mostly you will have sodium chloride, but the type of water we were dealing with, that has substantial amount of other high-value minerals too. As I mentioned, calcium, magnesium, strontium, and lithium, which we are working on right now. So the type of water we are dealing with, or we dealt with, that completely changes the game, because it's just the different type of water we are dealing with and different type of water we are aiming for. Obviously, the overall workflow cannot be applied in general to any produced water that is being produced in the industry, but we have to be specific, we have to be careful. The correct target and the correct produced water we are interested in to make this overall process more economical. So that's my final point to you. Thank you so much for your interesting comments.
Thanks for the question. We will take only one question.
Yeah, this is Mundar Al-Batashi from PDO. Thanks for the nice presentation. You just showed that water stress map,
Yes.
and where's the water scarcity maybe in the region. And you referred to the produced water as kind of one maybe of the solutions to tackle that issue. But looking at the produced water, it's not only you can treat it to the TDS, certain TDS level, so you can use it for the human consumption. There are plenty of impurities, and I don't think we are still there. We can take the produced water for the human consumption or to the food chain, maybe to make money, as you mentioned, maybe to extract things or to take to the biosaline. But I don't think we're still ready to take the produced water to the human consumption sector.
I agree with you, and I will go back to, okay, fine, this is already gone. I agree with you 100%, maybe 1,000% if possible mathematically. The main aim to show the last slide was not to give an idea that we can use the produced water and we can get rid of all our problems. The idea was to come back to our human essence of the importance of saving water, maybe by a small means within our capability. Maybe the tap is going on for 30 seconds more. And if you combine that with the overall population of a country, that's a huge value. So that was the overall message I was trying to pass on, not the direct correlation between we treat the produced water and use it for human consumption. So that was the overall idea in general. Thank you so much.
Our next presenter will be presenting a novel non-thermal plasma solution for VOC removal from industrial water systems. Mr. Hussein Movla. He's the Chief Technology Officer and co-founder of the Western Plasma Technologies. Mr. Hussein brings over 15 years of experience in new product developments and R&D operations, industrial manufacturing, and project management, with multiple projects completed, driving innovation in desulfurization, water and wastewater treatment. He's also driving the technical and part of the company, and ensures the company remains at the forefront in technological development. Please help me. Please join me in welcoming Mr. Hussein. Please.
Thank you very much. Hi everyone, and welcome to Oman Water Week. And my name is Hossein Mola. I'm the co-founder and CTO of the Western Plasma Technology. And I'm very happy to be here with you in this conference and present our solution for volatile organic compounds removal from the industrial wastewater. Yeah, first of all, I want to introduce our company. Our company working on the R&D by using the industrializing plasma technology. We have different type of the technologies, include some kind of the technology for water and wastewater treatment, and also our patented technology for desulfurization of the oil products, and also plasma for food treatment. And this is how our R&D team works in the recent years to develop some kind of the technology. And we have a portfolio of the new advanced technology who focused on industrializing the plasma technology. First of all, I will introduce our works and the problems of the water. You know that we have a number of the problems in the water and wastewater industry, including the physical risks such as the water scarcity, salinity, especially in the Gulf region countries, and also the regulatory risk. And with them, we have some reputational risk. And everybody knows that we have a number of the problems in the water and wastewater industry. We have some kind of the technology, but industry until now cannot solve the problems with the efficiency and cost of the water and wastewater treatment. So we have a very huge market in the water and wastewater industry. If we take a look for the potential markets in the Gulf region and also in the developing countries, we have a number of the markets like the oil and gas and the chemical industries, and also mining and metals, because all the new factories and manufacturing companies go to complex chemical materials, and it is not possible to treatment the wastewater of these companies with the conventional methods, and we need to develop new methods. If we take a look to the water and wastewater treatment market size, it's a huge market, and in coming years it reached to $52 billion, and in the case of the waste treatment technology, the CAGR is about 6%, and also you can find the data for the industrial wastewater treatment. If we take a look to the Oman water and wastewater water demand, we see that from the 20 years ago, the domestic and agricultural and especially industrial water demand grows about multiplied by 4 since the 2000s, and this is a huge demand for the water and wastewater treatment, especially in the case of the wastewater, because industrial growth in Oman is a huge, and this data from the United Nations water section. And so because of this, we need management, and we need a novel and innovative methods for treatment wastewater from the industrial factors and industrial applications. Yeah, here you can find our solution. After the years of the research and developments, we combine these 3 different technologies to achieve our advanced plasma oxidization method, or the abbreviation is APO. We combine plasma technology, chemistry of electrolyzing, and also the advanced material science to develop our new method. Our method, we tested in the lab environments, but we need to develop this to the industrial scale. If we take a look at the physics and chemistry of our system, you see here the VOC in the oily sewage water, and by applying the plasma in this, we can create some kind of the oxidized molecules, and these oxidized molecules react with the VOCs, and after that, we can settle down all these chemical materials, and after some kind of the filtration, we can produce clean water. And if you take a look for our technology, we know that the wastewater treatment technologies have a number of the problems, especially in the industrial wastewater treatment. All of them use the chemical materials, but in this method, we don't use any chemical materials, we only use electricity. And also there is some, so we test it in the lab scale, but we need to go to an industrial version and industrial scale test. So we tested it in the Tabriz Petrochemical Company by helping our university years ago, and we installed our system. You can find this in installed devices in Tabriz Petrochemical Company. Our devices efficiently remove the volatile organic compounds about the 77%, and decreasing the COD by 70%. After tested it, we go to the another main measure in the industry, the energy efficiency. So we recorded the data for the 30 different days, and we reached the the average energy consumption. And you can find that for this type of the wastewater, the energy consumption is about 1.5 kilowatt per cubic meter. So after installing the pilot version, we go to our demo plan version, and you can find our plasma reactor here, and we successfully removed the COD and also VOC by 80% and also 81%. And this is a huge forward for our developing technology, because we finally reach a standard design for this type of the wastewater, and we go forward to design the customizable treatment plant design. You see here that this is a very, very complex, very, very small sizes, and also efficiently remove the wastewater chemical hazards. And also we install some kind of the system for the pharmaceutical company, and efficiently remove the toxic materials and also non-biodegradable materials. So because beside of this, we tested our devices in the pilot version for removing the heavy metals, and you can find the data here. And by doing this base version, we go to the removing the heavy metals from the drinking water. In some part of our country, we have some problems with the heavy metals in drinking water, and in this case is the arsenic. This is the factory manufacturing process for devices, and finally we installed our system, and this system is the final version, and is efficiently remove heavy metals from the drinking water, and especially designed for the arsenic. You can find that the arsenic concentration is below that standard concentration for arsenic. Besides of that, my colleagues do some kind of the extra tests for this water, but it is not our goal, but the output water from drinking water also shows some decreasing some kind of the bacterial and microbial reports. And behind our works, we have a roadmap, and we have the phase-it roadmap. You can find here that in the phase 1, we are talking about the feasibility studies of our technology, and going forward to industrial this. In phase 2, we optimize our technology, developed, installed our systems in the pilot scale and demo plans in some kind of the industry. And in phase 3, we are go to international cooperation and go forward with the new markets and new techniques. And it is very, very important for us to be international cooperation, because some kind of the new technology needs some new markets and new investments. So if we take a look, the most important markets, the MENA region is the fastest growing markets, and also the best market is the China, India, Australia, and Canada, and also the United States. And behind any innovation, in the country, in a company, there is a big team. Here you can find our team of engineering and researchers who have years and years R&D experiences and develops this kind of the technology. And you can find some kind of the awards and honors about our technology, not in the wastewater. Also, we have in the several areas, so we have the R&D. And finally, I thank you very much for contribute and hear my presentation. And we are Investor Plasma, our headquarters now in Iran, but we have recently we opened our office in Canada for going to the international markets and North America market. We have a huge market there, and we also have a very good relation and very impressive for having international cooperation and starting our company division and startup companies in the Gulf region and Oman. Thank you very much. Maybe it's short. Yeah, okay. Thank you very much.
I would like to call Dr. Shan Young. She's the Vice President of Business Development, Trevi Systems. She'll be talking about solar-powered pressurized forward osmosis brine concentration plant for produced water from oil and gas fields in Oman. Sorry. Okay. Dr. Shan has more than 20 years of experience in business development, innovation, and technology and project management. She has worked for global technology companies, Veolia Water Technologies North America, same corporation, Industry Singapore, and Safbon Shanghai as well. And she has worked as well with startups and as well with diamond and gold investors in Nevada. You're welcome. The stage is yours.
Thank you, everybody. It is a pleasure to be here. My name is Sean, and I'm with Trevi Systems. Today, I'm going to talk about solar-powered pressurized forward osmosis for produced brine concentration. Just quickly, Trevi is a California-based forward osmosis startup. Well, maybe not startup. We've been around for a long time trying to perfect this technology. And our technology is meant to treat some of the most challenging wastewaters. And essentially, we will deliver zero liquid or minimum liquid discharge, as well as off-the-grid forward osmosis systems. We were founded in 2010, and our technologies are safeguarded by 78 patents covering 21 countries. Here you have a photo of a containerized FO system for produced water. Some of the locations where we have plants and pilots, we did a pilot in the UAE for seawater desalination. This was a project run by the Masdar Group. It was a competition, actually. And we did manage to desalinate seawater for under less than 1 kilowatt hour per meter cube. We have also built the largest seawater desalination plant in Hawaii. It's 500 tons per day, and we managed to get 65% recovery and potable drinking water. We also have a pilot that runs on renewable energy. The Hawaii plant was 100% renewable energy as well. Forgot to mention Cyprus as well, seawater desalination, renewable energy with the CSP panels, which look very cool. And we also have a pilot in Kuwait. So what is forward osmosis? I'm sure many of you guys here are very familiar with reverse osmosis, but let me just recap. Reverse osmosis, you essentially have high pressure, you have water against a membrane, dirty water, seawater, produce oil and gas wastewater. You exert a really, really high pressure against the water, against the membrane. Essentially, you'll get clean water on the other side, and you've got brine or the dirty brine on the other side of the membrane. With forward osmosis, Trevi has developed a very interesting polymer and what we call the draw solution. Here, under low pressure, you put the draw solution against the membrane and the dirty water on the other side. Essentially what happens is the draw solution, through the process of osmosis, it actually pulls clean water across the membrane into the draw. And you leave the seawater or the concentrated brine on the other side of the membrane. This is completely done in a very low pressure environment, so there's no external pressures. However, on the other side, you have got water as well as the draw solution that is diluted. By applying low-grade heat, maybe 80 to 90 degrees Celsius, we are able to cause the separation of the water from the polymer. And so the concentrated polymer or our draw solution drops to the bottom, it is recycled, and the fresh water on top can be separated out. This is very similar to if you go swimming in the ocean and you swim for too long, your fingers get wrinkled, right? It's just because the water in the cells are moving out via the process of osmosis, and you've got wrinkled fingers. But that is leveraging nature, to do such a desalination process. So what is the core of our technology is basically we have developed a thermal-responsive draw solution that has really, really high osmotic pressure. Osmotic pressure is around 4,000 psi, so about 260 bar. Typically reverse osmosis, max, it goes up to 160 bar for ultra high pressure RO. On the next phase is sort of the phase diagrams where it shows that at certain temperatures, there will be a phase change. And so that is the, so when you heat up our draw solution, it's able to detach itself from the water and then it can be recycled. However, when the draw solution is cool, it exerts that osmotic pressure against the membrane. Some of the value propositions of forward osmosis, because of the ultra low pressure environment, CAPEX is lower as well as operating OPEX is lower. The high osmotic pressures of the draw solution allow us to do brine concentration, enabling minimum liquid discharge. We have got more than 300 draw solutions, obviously safeguarded by patents. And all of Trevi's draw solutions used are food grade safe and non-toxic. Because of the low grade heat or the heating up aspect of the draw solution to cause separation, we are able to use solar thermal heat, renewable energy, waste heat from plants to power our desalination process or brine concentration process. Okay, so for our project in Oman, the site is about 38 kilometers south of Muscat. The goal was to reduce brine volume for evaporation and using renewable energy while we're at it, right? So we essentially were to design, construct, and operate, plus commission this produced water plant with 140 meter cube per day capacity. This is the output. So it's around 1,000 barrels per day output using renewable energy. Input feed water was pretty high. Typically, not what you would feed into a RO, but it was about 100,000 TDS. And the target recovery for this project was about 50%. So, the output brine TDS was about 200,000, 210,000 to be accurate. Input volume, 280 meter cube per day, approximately 2,000 barrels. So our main technology was forward osmosis, utilizing a very, very concentrated draw solution. The permeate we have designated for agriculture reuse. And this is sort of the plant that's being constructed out in Oman. Underneath the two containers are where the forward osmosis system is. So this is the typical produced water process train. I'm sure all of you guys are very familiar with it. So you've got your DAF, oxidizer, it goes through sort of a pre-treatment, GAG, and then it hits the reverse osmosis or ultra high pressure RO. Then you've got a polish step, and the remaining brine you send to an MVR evaporation tank or deep well injected. This is the Trevi process scheme for brine concentration. Our feed was 280 meter cubes per day, as mentioned, TDS 100,000, boron was greater than 50 ppm. Oil was ranging between 50 to 100 milligrams per liter. The temperature, 30 degrees, depending on the season, right? And so we would put it through a pre-treatment process, a membrane pre-treatment process, because at the end of the day, forward osmosis is very similar to RO. It's a membrane process, and we have to protect the membranes. We had a 3-stage forward osmosis system and we hit 50% recovery. What happened was after the forward osmosis system, we had a weak draw, and this was sent through polymeric heat exchangers. Polymeric heat exchangers is something that Trevi has also developed in-house in order to scale up forward osmosis, because stainless steel heat exchangers are really expensive to ship across the world. And so, that is a patented technology that we have. And so using polymeric heat exchangers, we were able to use solar thermal power to regenerate our draw solution. And so the draw solution will be circulated back into the forward osmosis system after the coalescer. And there's going to be a polish step with the permeate water. We had a polished NF to get rid of the residual draw solution, which are pretty big molecules. We've got an RO and a GAG. And so the output brine, the output permeate was, the TDS was less than 500 meter cubes per day. Boron was less than 0.5 ppm. TOC less than 5 ppm. As somebody mentioned in the thing, we shouldn't be using produced drinking water that's clean for drinking water. produce brine water that has been cleaned for drinking water, and I tend to agree. This is a treatment train of the CAD drawing of the Oman plant. And this is another view. In the middle, you have got your forward osmosis membranes, as well as your different NFs, plus the RO polishing. And in the front, you sort of see that is the pre-treatment aspect. So this is the thermal storage tank where we essentially got hot water that we use to basically run or drive our forward osmosis process. You have got forward osmosis membranes here on the left, and you've got your NF ceramics, and then you've got your polished NF membranes plus your brackish RO element just to polish the permeate water. So this is sort of a cost analysis, a rough cost analysis that Trevi did with regards to our forward osmosis MLD. We think we are pretty comparable to high recovery RO as well as ultra high pressure RO, but bear in mind the capex for our system will be a lot less because we're not using, it's not under high pressure, right? And with a crystallizer, it's completely a different animal. Okay, 5 minutes, okay. And with a falling film evaporator, we are somewhat comparable, but our capex will be lower because of not as much stainless steel in the system. So this is the technology for sort of produced waters and where we sort of see where forward osmosis lies. Essentially, I think we are somewhat on par with ultra high pressure RO, osmotically assisted reverse osmosis, as well as touching the limits of MVR. What Trevi is looking for in the Middle East, we have established an office in Oman, so please come and speak to us after the talk or the session. But we're looking for strong financial partners, potential licensees in the Middle East, clients who need cost-effective and effective brine concentration, MLD, partners who have waste heat and need water, as well as partners who have ESG goals and need zero carbon water treatment. Thank you very much.
Thank you, Dr. Shan. We have now the next speaker, Mr. Lawrence Redom. He is the performance manager for access to water sanitation in Veolia. He'll be speaking about AI and machine learning in operation and management. So Mr. Laurent has a rich background in water engineering and management. He brings 2 decades of expertise in the industry. He's working as Deputy Director Engineering at Europe Veolia and oversees service management and implementation of drinking water projects across Central and Eastern Europe. His role as General Manager as well involved managing of profit center at Veolia, where he designed, manufactured, and commissioned innovative drinking solutions, and as well municipality solutions for worldwide projects. You're welcome.
Thank you, Engineer Sada, for the introduction. Thank you, everyone, for attending this great event. So I'm going to introduce some AI and machine learning technologies in water operation and water management. And you will see I will take a different point of view in my presentation compared to a very technology-driven approach. First of all, a few words about Veolia. We are known for municipal operations, municipal water operation, but 43% of our clients are industrial clients. And we try to collaborate with the industries for to optimize their water cycles, their water production, and also the water they have in their process in order to get some good quality and compliance with this water. The strength of Veolia is that we combine our solution and our technologies in our three main business lines, which are water, waste, and energy. And our challenge is to accelerate ecological transformation through three main pillars. The first pillar is decarbonization, trying to go to a net zero carbon for the planet. Regeneration of resources, also targeting a net zero water footprint, and the depollution, trying to target a net zero untreated pollutant. And with this approach and those pillars, we support industries' initiatives for the challenge you have concerning water, getting license to operate your system, your plants, improve the water resource efficiency. We have reduce volume of resources, and we have to use it the best we can, and being profitable in your activities. As an industry, you also face the challenges with water. The first challenge here I point out is water scarcity. In some parts of the planet today, we have to select what will be the usage of water for industry, for people consumption, for agriculture. So this becomes a challenge. Global pollution, with all human activities, water bodies are getting more and more polluted. Rising awareness of people, the citizens are now looking after safe environmental management, to take precaution, and they want a large communication. They want to know what's happening behind the walls of our activities. And we are all facing a competitive market because the price of materials, of resources is increasing, the price of energy is increasing. We are in a competitive world, so we have to remain competitive. So for those challenges, even if your industry is not water-driven, here we have a lot of oil and gas and many other industries, in many cases, water becomes a challenge in the industrial activities. In your operation, in your industrial operation, of course, you manage a lot of data. The data coming from your systems, from your SCADA system, from your equipments, but also data from the documents you have concerning your machines, your best practices, your experience, your archives, real-time data, IoT, the data fed by your people on site who are filling some documents, taking some notes, etc. Many data. And the operators on site have to use as much as possible all of this data to do a good job, to be efficient. What we try to leverage now at Veolia is to use Gen AI, those new technology, LLM systems and these new technologies to accelerate this access to data with a new interface for the operator. So it's not rocket science, it's using those new technologies, but connecting them to the data we have in order to make them available in a smarter way to the operators. So the previous slide was interactions between the data and the AI with operator. Of course, there are some AI solutions which are directly plugged to optimization of our systems, communicating directly to the PLC, to your plants. And with those technology, we can improve, of course, the consumption of water, of energy, of chemical by optimizing your processes thanks to the data you have and some smart calculation, generally rule-based, taking into account physical law we all know, but accelerated thanks to AI and digital solutions. I will give you a few examples of solutions we have at Veolia for the operation we manage and for the benefit of our customer. The first one I want to mention is upgrade water footprint. This is not a rocket science tool. It's just a question of giving an access to a single source of truth of data. So managing a clean collection of data, preparation of this data, qualification of this data, make the pertinent KPIs, which gives you a good indication of the performance of your process, and expose this to your stakeholders, your operators, your management, your administration, in order to share all the same understanding of the situation. This is the basic, very fundamental point to start with, and after we can build other things based on this reliable data. This is a development we have in Veolia for all our activities. We call it Talk to My Plant. It comes to the previous slide I showed you just before, how to enhance a digital assistant for all your operators that can access to all the data you have on the plant, whether cold data, all the reference documents you have on all the equipment you manage in your plant, plus the hot information, the IoT, the live data. So we begin to elaborate, thanks to this technology, some standardized prompt in order to give the possibility to an operator on site to have recommendation, instructions according to the present situation he has on the plant. And this type of assistant in Veolia, we promote it in all the organization, and I think it can be used in any kind of administration, in any kind of entity, to implement an ecosystem with Gen AI to empower, to augment your people in your teams, etc., using this solution for the day-to-day task in order to interact with the huge amount of data they are used to work with, and to begin to bring some insights and recommendation. And the way we did it in Veolia, and this is something that can be also inspiring, is we wanted to avoid to have leaks of information, leaks of data in open cloud, open data. So we built a secured environment in a secured cloud, and we plugged on this cloud the commercial solution, the AI LLM algorithm of the market. Meaning that the 200,000 people of Veolia can use this technology in a safe way. The information does not escape. So this can be done in any kind of administration or industry. So we build some specific assistant, meaning for some routine interactions we have, we made some standard prompt, and we identified some libraries of documents which are interesting for this particular case, in order to create some kind of digital assistant where the operator can talk to those virtual assistants in order to have answers to their questions and to collaborate with them like a real assistant, actually. So with this technology, which is very accessible, it's a LLM, it's very, very accessible. With this technology, we can augment our operators on site, but also the managers, any kind of team, because we all in our day-to-day job can have interaction with this type of technologies to better work. And the next step is really to make some automation thanks to those technologies. Meaning, for example, by digitalizing some specific workflows, interaction with different software, and automating some processes, some routine processes in our jobs. So this is what we develop, and this can inspire other entities, I think. Few words about some example of technical management of some equipments. One of a more known equipment, the cooling tower. We find cooling towers in many industries, and this is a significant cost. So we automated some AI solution to better monitor and optimize the operation of the cooling tower with predictive algorithms. We have also some solutions for membrane in Oman Water, near to here. It is implemented again to collect all the data you have in a reverse osmosis plant, normalize this data, the job that your engineer do on the plant, normalize the data and follow the evolution of the membranes in order to anticipate the fouling and avoid the downtime. This slide to explain what could be next. In the first part of the slide, the top part of the slide, you see the operator in the plant who is operating the plant, the systems, etc. And he can communicate with this digital assistant to get some information, recommendation. And the next step could be what we call the fourth level of digital twin. The algorithm, the robot will be inside of your plant, taking actions in your plants with some automation, and the operator will be outside, giving some instruction, receiving some insight, and piloting the system. But this time, the robot is inside your plant and taking some actions. And these four messages I wanted to push at the end of my presentation. First one, data. In all of your activities, you manage a lot of data, and you know that data is the fuel for AI. But bad data will give you bad results with your AI. So it's very fundamental at the very beginning to begin to have a discipline on data, to structure your data, which is your legacy. Second point is the fact that we accumulate different systems from different suppliers, your history, what you have in-house. We have to struggle to make sure all those systems can interoperate together in order to build more value and avoid to have some silos. Third point is the black box effect. With this type of solution, you can have a system which gives you some answers, recommendation. You don't know exactly how it was built. However, we remain responsible of what we produce, what we write, what we do. So we always have to take care of what is produced by those algorithm, AI in particular. And the last point, people. The AI and the systems will never change the valve, will never make some adjustment on site, etc. You have people in your plants, in your site, and we have to onboard those people. They are the ones who are providing data, and they are the ones who are using the recommendation of data to make your operations. So people is a key part of the challenge. I thank you very much for your attention.
I'd like to call Mr. John Ali. He's the regional manager, Middle East region, Litas company. He will be speaking about advancing sustainable lithium extraction using nanotechnology. It's a direct lithium extraction. Is he available? Sorry. Yeah. So Mr. John began his career in UK manufacturing sector, then progressed to oil and gas industry, relocating to Middle East in 2004, where he spent time working in the US and across GCC, initially performing testing, cementing, and stimulation services as engineer, progressing to technical manager and operation manager in the upstream services. And now, he's with Litas, I think, since 2024, focusing on lithium extraction.
So hi, good afternoon, everybody. I hope all's well with you today. So Thank you for the introduction. So this afternoon, I'd like to give you all an introduction to our direct lithium extraction, or DLE technology. So the global transition towards net zero has created a strong increase in demand for metals, from the grid to electric vehicles to the batteries that power our smartphones, laptops. Battery metals are the key to making our technology-driven lifestyle sustainable. So the demand for metals is rising, and automotive manufacturers around the world have committed to an energy transition that requires far more lithium than we are currently producing. By these projections, by 2030, the world will be short over 1.2 million metric tons of lithium. So this is around a 600% increase in demand compared to today's requirements. So currently, over 250 billion barrels of produced water are generated annually. This produced water and brine contains critical minerals like battery metals, including lithium. So at Litus, we've designed an environmentally friendly, sustainable and scalable process for extracting lithium from wastewater, produced water and brines. This process is called Litus Link. So the Litus Link process, it allows us to work with the lithium, geothermal and oil companies, utilizing the produced water and our Litus Link technology to extract the lithium, which is in turn processed to make batteries for electric vehicles. So the Litus Link technology in the process uses nanomaterials to filter the wastewater, produced water and brines to extract the lithium. It's a process called direct lithium extraction, or DLE. So the nanomaterials are robust, they're highly selective, requiring less pre- and post-processing than other DLE technology to produce a high-value lithium product. So after successfully designing and testing in the lab, we then constructed a small benchtop model, which also proved successful. The next step was to build a portable pilot unit to prove the technique is scalable and allow us to demonstrate on-site in the field and at customers' locations. So Litus's team of experienced industrial nanochemists foresaw the fragility and scaling problems and developed ultra-robust nanomaterials that enable low-cost and selective extraction of lithium from low-concentration sources. It's economical and at an industrial scale. So Litus Link is very selective. It leaves behind the impurities such as magnesium, calcium, sodium, and potassium that are expensive to remove. Litus Link also recovers a greater percentage of lithium than competing processes, making it far more efficient. So nanomaterials offer a rapid absorption rate, a high absorption capacity due to the increased surface areas that they have. So they're thermally stable, environmentally friendly, highly selective, and can be reused further, reducing costs and increasing the overall efficiency. So as the nanomaterials are produced in-house at Litus, we can also further customize these depending on the water sources being used to ensure optimum efficiency for our customers, and further improving the economics compared to other extraction methods currently being deployed. So the important part of creating a solution like this is to ensure that it's scalable. And we've designed our solution with a vision of going from the lab to commercial operations. So we created our own facility to manufacture all the nanomaterials in-house. This is the first for Alberta and Canada. We also validated our performance at large-scale production, and our pilot unit is currently operational. It features a modular design that can easily be scaled up to a commercial level. We've also built strong patent protection and have a pipeline of additional IP. So at Litus, we've performed extensive testing on wastewater and brines sourced globally to allow us to further enhance our Litus Link technology. So the Litus Link technology has more than a 95% extraction efficiency and selectivity against other elements. So the wastewater is filtered, the lithium is extracted and retained in the nanomaterials contained in the filter housing. So once the filters are saturated, they're flushed with hydrochloric acid to extract the lithium in the form of lithium chloride. The filters can then be reused. So when compared to other current lithium extraction methods such as brine ponds, hard rock mining, and conventional DLE, Litus Link performance shows a very short construction period of less than 1 year. It has the highest recovery rates of 99% and the lowest CO2 emissions. In addition, Litus Link has both lower water and reagent use, resulting in low capital costs and operational costs compared to other lithium extraction processes that are currently being used. So given our excellent performance in extracting lithium from low concentration sources, energy companies have the expertise, infrastructure, and resources in place that as a collaborator can help us bring our technology to commercialization. So in fact, we're currently extracting lithium from produced water that are available and currently going to waste. So our group's expanding our reach into conventional lithium brines and finally broadening our reach to address the entire lithium market of around $51 billion. So the Litus Link pilot unit, it's a plug-and-play unit, so it doesn't disrupt the current operations, and the wastewater that's being filtered can continue to be used, re-injection, etc. So it's basically, you can see from the picture, it's based in a sea can. Depending on the requirements, it could be a 10-foot, a 20-foot, or a 40-foot sea can. The 10-foot sea can filter around 10,000 liters per day. It'll actually go up to around 12,000 liters per day, so it's pretty efficient, and we can scale that up. And the good thing, when we say it's plug and play, it just fits into the operation. So you'd have your wastewater coming out, you would then filter that with a 5 or 10 micron filter just to clean it up. You would run it through the unit, it would pull out the lithium, and then the water would come out the other end. So if you're re-injecting that water or utilizing that water for something else, you haven't lost the water, you can still use the water. The good thing, it's an additional revenue stream because it's pulling that lithium out that would have been re-injected downhole. So in addition to that, we can manage the whole project in that we manage the disposal of the wastewater as well, if that's something that customers would be interested in. So the Litus Link unit requires a power supply, then the rest of the process is fully automated. The built-in communication protocols ensure reliable data transfer and connectivity, which includes automated monitoring, safety shutdowns, and system controls. These are all further enhance the efficiency. They lower the extraction costs compared to other DLE technology. So with the increasing demand for lithium, Litus is exploring collaboration opportunities that could revolutionize the industry through joint ventures that provide access to Litus Link world-class technology. Litus offers exceptionally high rates of lithium extraction as high as 99%. Our technology is a powerful solution that could disrupt the industry. So Litus has the potential to become the primary infrastructure for lithium extraction, offering a straightforward one-step process that guarantees exceptionally high extraction rates at a competitive cost. So in closing, energy is the most important market in the world. There's a demand for lithium, and we have the solution to solve this problem, unlocking new sources of lithium globally. So we're excited about this opportunity and what our solution can bring to the world. So thank you all for allowing me to present our Litus Link technology to you all today. Thank you.
The last presentation will be for Ms. Amna Rasbi. We'll be talking about novel approach for sustainable organic pollutant removal from refinery wastewater using nanotechnology. Ms. Amna is working as a project research officer at OQ. She's a dedicated chemical engineer with bachelor degree, specializing in research and innovation. She focuses on applying nanotechnology to address environmental challenges and promote sustainability. She has received prestigious awards for her outstanding contribution in advancing solutions for greener future. Welcome, Ms. Amna.
Assalamu alaikum. Good afternoon. I am Amna Rasbi, an independent researcher and inventor. So, as you know, oil refinery is one of the fast-growing industry across the globe, and it's expected to progress in near future. The worldwide increase in the generation of oil refinery, along with the environmental regulation effort, have been devoted to recycle and reuse this treated water. Refineries use a ton of clean water during their process, but they end up creating as much as oily wastewater. Thereby, it's lead to an environmental issue. Thereby, this project focus on how synthesis of tiny super effective particles called nanoparticles to handle the cleaning process, especially using a silica nanoparticles using adsorption techniques. The main objective of this project is to establish an eco-friendly and sustainable approach to the wastewater treatment, aligning with the country's international commitment to the Paris Agreement and also future climate conference like COP29. According to OQRBI, the data from 2024, the refinery generates around 260 cubic meter of wastewater per hour. That means more than 6,000 cubic meter of wastewater. Treating such large amount of water is not easy, especially when it contains a very complex pollutants. That's why finding an efficient and sustainable solution is so important. As I mentioned, oily wastewater is a serious environmental concern. Although there's several treatment methods are available, such as advanced oxidation, microbial technology, membrane technology, and other technology, which are economically not viable. This is usually come with a higher operational cost, more sludge volume, and also sometimes create a secondary pollution, which required a further treatment step. Also, the traditional methods are less effective in removing color, dissolved solid, suspended solid, and also turbidity. This makes many existing solutions not only inefficient but also economically unsustainable, highlighting the urgent need for more effective and lower cost technology. This project is aligned with the country, with Oman's strategic goal by promoting environmental sustainability, aligning with the international climate commitments like Paris Agreement and also COP29, and improve the refinery wastewater treatment efficiency to reduce the cost and also the environmental impact. This research proposal is designed to address a refinery wastewater treatment through a structured approach. We start with the synthesis and characterization of silica nanoparticles to ensure they are effective for organic removal. Then we conduct a detailed analysis of refinery wastewater to understand the composition and also identify the main contaminant. After that, we focus on identifying the optimal operating conditions such as pH, stirring time, stirring speed, and also the dosage of the nanoparticles to achieve the best treatment performance. Also, we carried out an environmental impact assessment and explored the reuse of these nanoparticles after the usage, aiming to reduce the waste and lower the cost and make this process more sustainable in lower term. In this project, we developed the nanoparticles using a Stober method. To understand their structure and properties, we use several characterization tools like for field emission scanning electron microscopy, Fourier transform infrared spectroscopy, and also the X-ray diffraction. The batch adsorption study were conducted by performing, as I mentioned, the pH, stirring time, stirring speed, and also the dosage of the nanoparticles. After the treatment, the nanoparticles were separated using a centrifugal separation, and the resulting particles are washed and reused for several cycles of treatment, thereby saving a considerable amount of money and hence reduce the environmental pollution. This is the characteristic of the refinery wastewater sample. The characterization of the silica nanoparticles confirmed the successful synthesis of these particles. The surface characterization and identification of functional group were carried out using scanning electron microscopy and Fourier transform infrared spectroscopy, while the phase identification and grain size were performed using X-ray diffractometer. You can see in the SEM image that the nanoparticles are well distributed, spherical in shape and almost 100 nanometer in size, while the EDX spectra confirm the presence of silicon and also the oxygen. And here you can see the XRD and also the FTIR spectra for the nanoparticles. We compare our result with the previous result to make sure that the particles are uniform. Looking at this result, we can see how different factors impact the COD or chemical oxygen demand reduction using silicon nanoparticles. The highest removal, 67%, was observed at pH 4, where contrast between the particles and the pollutant was the strongest. For the stirring time, the optimal duration was 19 minutes, achieving 69% reduction in COD. This is when the equilibrium was reached. Regarding the dosage, using 0.5 gram of silicon nanoparticles give the best result with a 65% reduction. Lastly, the stirring speed was 125 round per minute, resulting the best performance with 67% reduction. These results clearly demonstrate the ideal condition to achieve the highest treatment efficiency with the silicon nanoparticles. As part of our future research direction, we aim to explore 4 key areas to enhance the water treatment using a nanotechnology. First, we will focus on multi-pollutant removal by creating an advanced nanoparticle that can be removed different types of contaminants, such as organic components and also the heavy metals. Second, we plan to integrate the nanoparticles with the membrane filtration, and also we work on nanoparticles regeneration. And finally, we explore to use artificial intelligence in wastewater treatment. By applying AI and machine learning, we can monitor and adjust the treatment process. I believe this effort will support the development of more sustainable, cost-effective, and intelligent wastewater treatment technology. This project has been more than just a research. It was inspired by a real-world problem faced by the oil and gas industry. Refineries wastewater is not just an environmental issue on a paper, it's a challenge that has a direct impact on our ecosystem. What makes me most proud is knowing this research project didn't stay in the lab. It has a potential to make a real difference. This recognition you see in all of these photos shows the project success both locally and international platform. A proof that when the science driven by a purpose, it can create a mindful change. At the end, this project extends beyond water treatment. It's introduced a sustainable, eco-friendly solution, implying environmentally friendly nanoparticles that can recycle and reuse. These solutions offer a cost-effectiveness, environmental sustainability, and zero waste generation, perfectly aligned with the Sustainability Development Goals and zero emission objective. And thank you.
I would like to thank all the presenters for sharing their innovative solutions and as well the best practices to achieve sustainability. Can all the presenters be on the stage, please? We'll open the floor for the questions. Please, Mr. Hussain. Any questions for our presenters.
Assalamu alaikum. My question is to John. For lithium extraction, what would be a sweet spot concentration of lithium in produced water that would make it feasible in your thought?
Normally we target around, Thank you very much for the question. Normally we would like it to be around 200 ppm. That is a nice sweet spot. We can go as low as 50. That was our initial trials where we considered it still economically feasible. We then tweaked the nanomaterials further and were able to get down to 30 ppm and still be economically feasible, basically. In addition, it's also the scaling as well. Sometimes to go as low, you cannot always scale up, but we were able to go as low as that and still scale up to the 10,000 to 12,000 liters per day, which still can be increased further. So thank you very much. Thank you.
Hello. I would like to thank all panelists. My question to Shan. Thank you very much for a nice presentation. It seems using EFO as a brine concentrator is promising in terms of energy consumption, right? But just I would like to make sure, have you considered thermal energy in this figure, specific energy consumption you compared with electrical energy?
Sorry, your question is?
Thermal energy required to recovery through solution.
It's around 35 kilowatt hour per meter cube.
This is the total electrical energy.
Yes, for the separation of the draw solution, yes.
3 kilowatt.
30. It's about
30 kilowatt.
Yes, 30 kilowatt.
I
But
think
that's thermal.
30 kilowatt thermal.
Yes.
I guess to be fair comparison between with high pressure RO, since high pressure RO is using electrical energy, right?
Correct,
And, so I think to be fair in comparison, you have to make equivalent for the 30 kilowatt as electrical, then add the electrical consumption of the pumps, then the comparison will be fair because you should really very low figure. It will be confused, when you say only about 2.5 kilowatt, which realities will be high. I mean, you have to make equivalent. Just this is my comment here.
No, and we agree, but I don't think that there is a very straightforward or there is no theoretical conversion from thermal to electrical. There are average numbers, but that is noted. So typically we say that for osmosis is a combination of electrical energy plus thermal, correct? And so then if you look at the whole picture in itself, you compare CAPEX and OPEX, but I do agree. I mean, it's not something that we say, and that's why we say if you can use reverse osmosis, use it. What we do is we treat reverse osmosis brine.
Yes.
Right?
Yeah, I can help you in that. I mean, 30 kilowatt thermal, just to multiply by 30% ranking efficiency. So it seems 30 kilowatt thermal about maybe 9 to 10 kilowatt electrical, plus 2, so it means, I think, average.
Correct, but then that is also run by renewable energy.
Okay, I know it's cheap,
so
but
so
you have
that's a bit different.
to make comparison free.
Correct.
Thank you. In a way, good work, excellent.
Thank you.
Okay, actually, my name is Professor Mushtaq Ahmed from Sultan Qaboos University, and I have actually the first thing to Veolia, that you are building big plants, a million cubic per day or even more, investing billions of dollars, but the job that you produce are only 20, 30, 40 per plant. And now you're even trying to get rid of that with artificial intelligence and robot. Is this ultimately that all you want is money and no capacity development in Oman and that? So this is one question you have to answer, because I remember in 96 in Gobra, one MSF plant had 300 people working. We don't want to go back to those days, but again, a huge plant in Oman, we think we need some jobs really. To Dr. Shan about forward osmosis, when are you going to go big? You are in 15 years in this business and you are having a plant of 140 meter cube per day. And that amount of water we can buy from Nama for 70 reals per day. And Oman was the first country actually which had a forward osmosis plant in 2011 in Al Nazda, which is 1,000 cubic meter per day. That was the only functional forward osmosis plant. So I don't know whether you know about that, but we have some record on that. So this is that, when will you go big? And for the Dr. John, that lithium concentration. We have checked lithium concentration in Omani brine, sea, wastewater. Nowhere you will get 50 ppm. So it's much, much less. So I don't know, unless you're talking in parts per billion, then probably there is a future. And for Hussein, again, the energy. You are getting into plasma, the carbon footprint. So this is the thing that, but your doses are very high, 500 milligram per liter or something like that. And if something that is all nature-based, activated carbon, they can do the work, why go nanotechnology? Just because nanotechnology is there doesn't mean that we have to use that. There are other, so these are comments and questions. If you care to respond, please do that.
Hi, thank you very much for your question. So I start the answers. Veolia, we are a worldwide company, and we really concentrate our effort for the ecological transformation worldwide on water, energy, and waste. And we really try to focus our effort where we have a stronger impact. Because we cannot go everywhere on every side, etc. So we really select the places where we think we can bring more values and more impact for our different targets. We are a multi-purpose company. Of course, we try to improve, to accelerate ecological transformation with the 3 pillars I mentioned. However, some of our stakeholders are the investors. We also need to remain profitable in order to continue to accelerate this digital transformation. So for sure, we concentrate our effort where it is profitable, and we also accelerate our effort where we can gain great improvement in our ecological challenges. So we have to select. And the second point also of your question about AI, machine learning, etc., we are like all of you. We have to take this into account in our operation to gain in efficiency and to gain in performance. We keep in mind, as I said in my presentation, that behind that there are people, there are operators, and the challenge we have is really to empower our people, our operation with those technology. We cannot ignore that, so we take the more benefit we can with that in our operations.
Thank you very much for your question. My feelings are not hurt. But, you know, I think I want to say forward osmosis, or at least water technologies, are notoriously hard to commercialize. As somebody who did my PhD in forward osmosis at one of, I think, the top universities in the US for forward osmosis. I mean, Oasis was a forward osmosis company that was born. They raised 50 million. They went bankrupt, right? And so, you know, I think when I did my PhD, there were many aspects of forward osmosis that had not been figured out. The draw solution, the membrane, the process, how do you actually utilize waste heat? I think 10 years for commercialization of a new technology in the water space, you know, it's valid, especially for a very complicated process, you know, that's as innovative as forward osmosis. I'm fully unaware of your plant that was built in Oman in, you said 2011? What, sorry? So then let me ask you, who was your provider? What was the draw solution?
It's for the brackish water. It's for the brackish water. What she presented here is for the hypersaline produced water from piping.
Correct. It is known in Oman, but typically, if you're comparing it to brackish desalination, I say go and use RO. Go use something which is commoditized and cheap. For osmosis here, what we are doing is for hypersaline. So typically, what reverse osmosis brackish RO cannot do, we can handle it. And as far as we know, our plant in Oman is the first of its kind, using renewable energy and doing brine concentration of such high concentrations. Yeah. And I'm happy to come and chat with you after to learn more about the plant.
Okay, I'll go next. Okay, thank you, sir, for the question. It is a valid point. I mean, we're fortunate here in Oman that we do have multiple operators. So there is a lot of brine and water and wastewater being produced in different areas across the country. So it allows us to see what sort of numbers they're producing. They are on the low end considerably. I mean, you're normally 10 to 15 ppm. The highest I've seen is around 25 ppm. But yeah, I mean, we've been down to around 30 ppm and it's still economically viable. So we are getting there. But I mean, DLE is fairly new technology, especially when we're using the nanomaterials. So we hope that we can get in that, you know, that sweet spot and basically be economical down to as low as 5 to 10 ppm, hopefully in the future. So thank you.
Hi. Thank you for your comments. First of all, we are now in a pilot stage, and as I mentioned, in one of our future work is to integrate our nanotechnology with another technology to improve the efficiency of the treatment.
Thank you very much, Dr. Professor, for your question. Actually, the main problem in the industry is that non-biodegradable materials, and when we are forwarded to chemical industries and pharmaceutical industries and also oil and gas industry, we produce a huge amount of the non-biodegradable compounds. And these non-biodegradable compounds, we should apply some new technologies for remove them. For instance, in one of the slides, you can find the Fenton method or another chemical methods. Producing these chemical materials, transport the chemical materials to site, and also depositing this, the byproduct of chemical materials have a lot of cost. And we solved this problem by using our technology where we used only electricity. And the electricity also have some kind of the GHG and also carbon footprint, but we can use this electricity from the renewable sources. For example, the solar or geothermal or etc. and wind power. And it's very easy to provide electricity in comparison with the providing chemical materials and also some kind of the other problem in the depositing the materials. And another problem is the supply chain for the chemical materials. For instance, in the coronavirus pandemic, we can't access to some kind of the chemical materials provided in the abroad, and we can solve this problem by using our in-house system and the clothes and providing some kind of the very low electric consumption in our devices.
Thanks,
Thank you.
Mr. Hussein. MashaAllah, Dr. Mushtaq have asked so many questions, so we'll take only 2 questions.
Yeah.
Yeah. Good afternoon. My question was with Dr. Chan Young. I'm actually very grateful that you are here because I've been following TRIVI for a long time. We've done a bit of research in Fort osmosis. We stopped because of all of the problems, and you know the problems with Fort osmosis. This project that you talked about is the Heliovest TRIVI Arab Petroleum, right? Project in Sih al-Maleh, right?
Yes.
Yes. قارة الملح, sorry, yeah, قارة الملح, sorry. I think the success of that project is going to be the success of the whole world because it's the quality of the water is, we know how notoriously difficult it is. It's more than 150,000 ppm, right? My question is, and I know there is a lot of things to discuss in that, but my question is, how did you deal with the back diffusion of all the nasty things that are in the water? And you know these Fort osmosis are the ones you used are RO membranes, right?
When
in
you say
nature.
back diffusion, you mean back diffusion of the draw? Or you mean the diffusion of the nasty chemicals into the draw?
Both.
Okay.
Yeah.
So we handle it with the draw solution. It's a very big molecule. So, you know, you don't have a lot of reverse draw solution backwards into the brine. Like, for example, Oasis, the company which is no longer around, they use ammonium bicarbonate, and that draw solution is really small, so there was non-stop of back diffusion. So that wasn't a good draw solution. Our molecules are really big. How do we prevent impurities from the brine into the draw? We use a standard forward osmosis membrane that is cellular triacetate. So the pore size is pretty tight. It's that of an RO. So with that, we prevent transport of impurities both ways.
Oh, great. So, and you don't expect any kind of biofouling because you are using CTA? Because I remember Modern Water did the forward osmosis in Al-Khuluf, I think Al-Khuluf, right?
Hollow fiber.
And Khuluf. And it worked, but it's brackish water, yes, but salinity was around 85,000. So it's not really brackish water, it's double the seawater salinity. But unfortunately, their recovery was extremely low. Less than 10 overall, I think, recovery. What is the expected recovery, and again, also biofouling? And thank you very much, really.
With the biofouling, I mean, like I said, the FO membrane is like a standard RO, so we will have to do cleaning. There will be downtime. It's treated exactly like a RO membrane. The only difference is the high concentrations that we are dealing with, and we hope to mitigate that with proper pre-treatment and monitoring the incoming feed water. Because as you know, in the oil field, sometimes there's spikes, sometimes there's no spikes. So with close monitoring, I think we can mitigate that to prevent a lot of the biofouling.
Is it in operation as we speak now?
It's currently not in operation.
Okay,
We
so
will
when
be starting
do we
hopefully
expect?
pretty soon.
Because we're all looking forward to see the
Trust me, me too.
results.
That is when we go big. Because this is the first of its kind. Yeah.
Thank you, Dr. Sham. We have only one question to take.
Thank you very much. I think a mix of technical, and the chairperson also facilitated very well. That is why so much questions coming to the host. My question to lithium. In the presentation, we did not see any of the reference listed. Do you have currently running plant in Middle East or any other reference? Then my next question is for the Western plasma. This drinking water heavy metal removal, do you have any limitation on the plant capacity? And do you have the plan for the boron removal as well? These are all my questions. Thank you very much.
Okay, thank you, sir, for the question. In the Middle East, currently, no, we do not have a plant operating. Our plant is in Calgary, so we built it in-house, and it's actually functioning now, so it's actually working for one of our clients in North America. But at the moment, we're still working on the BD in the area here. As the doctor mentioned as well, the lithium content is quite low here, so we're trying to find the best place to start off with. But currently, no, nothing in the Middle East, so thank you, sir.
Thank you very much for your question. And can you repeat your question about the boron? Boron metal. We didn't test it on the boron metal, but our system only working on the heavy metals, because we oxidize these heavy metals, and you know that these heavy metals and the heavy metal cannot be sold in the water or wastewater, and by separating, we suspend it in the water and filtering this and removing these heavy metals. But for instance, we cannot solve the problem for desalination and total solvent metals, for instance, calcium, lithium, or magnesium, because these oxidized metals can also sold in the water and wastewater. We only work on the heavy metals, and we didn't test on it. We do our tests on copper, lead, chromium and also arsenic in the case of the drinking water and also wastewater. The important parameter in the wastewater treatment is the electroconductivity, and if the electroconductivity is so much, we can control the electrical consumption. And another important issue in the wastewater is the pH, because you know that if the pH is very low, the oxidized metal also cannot be oxidized properly, and we should control the pH of the wastewater. Thank you.
With this, we close the session. Many thanks for the presenters for the insightful sharing of innovations and as well best practices. And thanks for as well for the questions and that really have brought fruitful discussions here. Yeah.
Thank you, speakers. Thank you, Engineer Saada. And now, as a thank you, we ask the speakers to receive the certificate of appreciation, starting with Dr. Saeed Haider, and we will receive it on his behalf, Maged Al-Qassawi. Please come to the stage. To the middle, you. Yes. And the next speaker is Hussein Movla. Dr. Shang Yong. Mr. Laurent. Mr. John Ali. Miss Amna El-Rasbi. All speakers, please gather on the stage for a group photo. Thank you all. That is the end of session 2. And now is the prayer and lunch. We will be back to the hall at 2 for the round table. Thank you and see you after. sequence of the roundtable and how things are going. Mundir, please, the floor is yours. Please welcome Mundir.
Yeah, assalamu alaikum, everyone. I hope you had a very great lunch. So welcome to the roundtables. I'll be chairing this session where I'm going to just tell you how we're going to run it for the roundtables, and then we're going to have it in, in a 3 runs. So the roundtables normally is a kind of multiple presentations will be presented at the same times. So we're supposed to have around 13 presenters and 13 topics to be presented at the same time in a 13 tables. And the tables actually, they are numbered from 1 to 13. Unfortunately for today, we are missing 3 presenters. Table number 1 will be presented by Safa, and table number 8 by Abrar. And the table number 3 is still, I didn't get the name, but hopefully we can see them by at least the run 2 or the 3rd run. So how we're gonna run it? So it will be, first we're gonna give you like a 5 minutes where you're gonna just go through the agenda, see the topics you want to attend, and you will be allowed to attend around 3 topics per this session. So you're gonna go through the agenda and see which topics to attend. Then after 5 minutes, we're gonna set the clock for 20 minutes where you can interact with the presenters, listen to them, and ask direct questions. After the first run, we're going to give you again 5 minutes where you're going to go to the next table. Then we set the clock again for the second run for 20 minutes. And again, after that, 5 minutes again for you to go to the 3rd table. And then the last session will be held for 20 minutes. So please start looking at your agenda. And the tables, actually, they are numbered from 1 from the far left and to the 13 there in the back. So just look at the topic. They are there on the tables. And look at the agenda. You will see the description of each topic. And you got 5 minutes to start the first session. So please bear in mind that some tables, they are still missing the presenters, so you can move to the other tables where they occupied by the presenters.
Please, can we have the list of speakers displayed on the screen? In a minute. Okay, here we go.
Yeah, guys, you can start for the first round. You got 20 minutes. Yeah. 5 minutes to go. Yeah. Yeah, so we done with the first run. Now we're gonna give you 5 minutes to move to the next tables, or you can pick the second topic from the list provided here in the screen. We're gonna start after 5 minutes for the second run. Ladies and gents, you got 5 minutes. You can pick the next topic from the list provided and you can move to the dedicated table. Number 1 and 8. Yeah. هذه كان استراتيجي. شوف رقم 2 هو عنده شوية شغل. Maybe number 3. You can still pick. Number 1 and 8 are not there.
He wrote his title and name, and I sent the guy Mike print it out again, and he's coming and he's printing.
So we're starting the second run. Please, all presenters, start the second run, and you got 20 minutes. Guys, so we done from the second run, and you got 5 minutes to choose the third topic. The third run will be the last, so please go ahead and check your third topic to be attended. Just, okay, for you? Okay, I was about to announce it. I know, yeah. Ladies and gents, this will be the last run, so please start moving to the dedicated tables. Please, all presenters start the third run. You got 20 minutes to complete. Sorry, guys, but we are ending the session with, yeah, this was the last run for today. And I would send my sincere thanks to all presenters for their dedicated time. I would like to ask the presenters to come to the stage for the appreciation certificates.
ممكن Thank you, everyone. And this will be the end of the second day for the conference. And now, thank you all presenters for your efforts. And now for the certificate of appreciation. Now we will start with Apik Banriji. Okay, thank you. Go stand in the middle. Fatima El-Mandari. Ishaq El-Kindi. A round of applause to the presenters, please. They've done a good effort. To you guys. Harry Pullman. Abdul Aziz, Abdul Salam. أدهري الكلباني. عمرو الرفاعي. المنتصر المعمري. عبد الرحمن علي المقبلي. دكتور وفاء عقب الرواحي. She's not here. Okay. Dr. Khalid will be receiving the certificate on her behalf. Aisha Al-Busaidi. Please, all the speakers gather on the stage for a group photo. Thank you all. That will be it for the day, and see you tomorrow, same hall, 9 a.m. Thank you.